I got this worksheet from Sir Bilal Hamid. God, that guy is good. He's so good at teaching and also so resourceful and so helpful. Yeah, we need more teachers like him. All right, so let's begin. The hydrocarbon C17H36 can be cracked. Which compound is the least likely to be produced in this reaction? Uh, we are cracking it, right? We are making smaller molecules, and all of these are smaller than this one. So there's a high chance that we can produce. There is a chance that we can produce all of these, but smaller fractions are more likely to be produced because if you let it continue for a long time, so it will eventually produce really small uh, fractions. So this one, which is really big, is least likely to produce. Okay, in the presence of ultraviolet light, ethane and chlorine react to give a mixture of products. Of course, this is free radical substitution they're talking about. Which compound could be present in the mixture? So you have ethane, okay, and you have chlorine. So where could you get a free radical? You could get a free radical if this one hydrogen goes away, which means you could get a chlorine here, or you get a chlorine here, or any number of chlorine displaced from this. Uh, but you can't get this one. That's impossible because you don't have one carbon molecule, you have a two carbon molecule. Similarly, you don't have a three carbon molecule, so B is not possible. Okay. And one option is that you take a free radical of this thing, which bonds with another free radical of this thing, and then that substitutes chlorine in there. Sure, that's a long shot, but it can happen. मतलब यहाँ पे क्लोरीन आ जाए बन सकता है but ये तीन कार्बन वाला कोई मजाक नहीं. You can get 4 carbons, you can get 2 carbons, you can get 6 carbons, very little chance, but you can't get 3 carbons.
Sir, how can you
Okay.
get 6 carbons?
We can get 6 carbons if this thing, once it's formed, decides to get a free radical here and it bonds with another free radical like this one. So it gets 2 more added.
Okay.
So you can elongate the chain like that. But in any way, you can get multiples of the carbons that you already have, but not 3 carbons. So you can get this one C. That is possible because you can get one ethyl bonding with another ethyl. Whatever the chances are, we are not calculating, but it can be produced theoretically. 5 carbons not possible. Which molecule could not be obtained from cracking of a molecule of a nonane? Nonane, and this is an isomer of nonane. Is it? No, this is not an isomer, it's a straight chain. This is one isomer of nonane. Okay, so what could you not get? You're cracking it, you're breaking it down. So sure, you can get alkanes, you can get alkenes, but because it's a straight chain compound, you're likely to get straight chains. You will not be getting branches, and you can get alkane, ho sakta hai. You can get smaller fractions as long as there's number of carbons less than equal to 9, sorry. And as long as it's straight chain, you can get alkanes, you can get alkenes. You can't get a branch, and that is D. D is a branch, it can't be there. The FRS reaction between methane and chlorine involves initiation, propagation, termination. Quick review, chlorine breaks down to produce chlorine radicals. This is initiation. That radical bonds with this thing, forms another radical and HCl, which then goes on to bond with chlorine and form chloromethane and a chlorine radical. So these two are propagation. So this is initiation, that's propagation. And then lastly, if any two radicals react together, they are termination. So chlorine radicals combining to make chlorine, or methyl radicals combining to make ethane, or methyl radical combining with chlorine radical, that's chloromethane, that is termination. Some few steps. You can get multiple other products. Okay, what is involved in initiation stage? You're getting radicals, right? Radicals are formed by homolytic fission. So, yep, homolytic fission. And radical produced in a propagation stage, you can get a methyl radical in propagation. You won't get hydrogen radical because hydrogen is not going separately. All right. or hydrogen wasn't bonded with something. So yeah, you get HCl and yeah.
Sir, why can't we get a
You get
hydrogen
included.
radical?
One option where you can get hydrogen radical would be if something were to approach chlorine and like if this chlorine radical were to come and approach this and this bonds and this bonds and this, still you wouldn't get a hydrogen radical. And chlorine के साथ bond क्यों करेगा यहाँ पे? Very difficult for that to happen. Bond strength of HCl is much higher than the
But
bond of HCl.
can't it just be formed when the other radicals are formed?
I don't get it. What will be formed?
The hydrogen radical.
Yeah, there's no chance that hydrogen radical is going to be produced here because either chlorine radical will come and react with it to make HCl, okay, or it will come and the only option in which that is possible is okay, chlorine radical comes and tries to bond with this chlorine. Okay? But the problem with that is that it's very difficult for HCl to split homolytically. Why? Because of high difference in electronegativity. You know, when they are sharing electrons, chlorine is much more electronegative. So if this tries to break up, HCl, we have seen it ionize and we have seen it split heterolytically. It's an acid, it splits heterolytically. Homolytic fission is key, pretty much impossible. Get it? Which equation correctly represents the balanced equation for complete combustion of hydrocarbon with the formula CXH5? Pretty straightforward. You have X carbon dioxide mate, okay, and you have Y by 2 water mate. We know that. If you have 3 carbons, you get 3 carbon dioxide. If you have 8 hydrogen, you get 4 water. And then how much oxygen do you have? You have 2 times X here and Y by 2 times 1. So you're getting 2X plus Y by 2 oxygen. Okay, that's what you're getting if you have a general equation. So X carbon dioxide plus Y by 2 water. That's the general equation. But which of these works for us? Let's see. Uh, hmm. If you're not getting 2x plus y by 2, you could be getting some multiple of that. What is a multiple of 2x plus y by 2? X plus y by 4 or 4x plus y, right? I'm just trying to multiply it with different numbers to come up with one of the options. If I divide it all by 2, if I divide it by 2, I get this one. If I multiply by 2, I get this one. So as long as there's a multiplication factor here and it's balanced on both sides, I get this as my answer. The citrus flavor of lemons is due to the compound limonene. This is in the ene family because of double bonds, as you can see. What is the mole ratio of carbon dioxide to water produced when limonene is completely burnt in oxygen? Okay, just figure out how many carbons and all that you have. Completely burned करना है इसको. So I have 1, 2. So this is 1, 2, 3. This is 6, and then 7, 8, 9, 10. 10 carbon dioxide. How much hydrogen do I have? Let's see. 3 here, uh, 2 here, 1 here, 2 here, 2 here, 2 here, 1 here, none here, 3 here. The total is 12 here, 8 water. Do you get it? I have 16 hydrogen, so I'm getting 8 water. So the ratio is 10 ratio 8, which is 5 ratio 4.
Sir, I didn't understand. How did you count the hydrogens?
Oh, I just counted the bonds of carbon and hydrogens are filler. So if over here carbon had 1 bond, I made 3. If over here carbon had 2 bonds, I put 2 hydrogen. Here it has 4 bonds, so 1 hydrogen. Here it has 4 bonds, so 0 hydrogen. जितनी carbon की bonds है ना, उसको 4 बनाना है. Crude oil is a mixture of many hydrocarbons ranging in size from 1 to 40. The alkanes in the crude oil can be separated because they have different boiling point. We call that process fractional distillation. What is the correct explanation for the difference in boiling points of the 3 isomers with MR72? This one, and this one. The primary difference is that as you get more and more branches, the van der Waals forces, they change their distance, their strength. Okay, that's a primary reason for any difference in boiling points. And the closer the shape resembles a sphere, the lower the melting and boiling point, because It has less surface area that is exposed for like dispersion of the electron cloud. So yeah, increased branches का आंसर होगा. So it says boiling point is dependent on length of chain. No, that is not, because van der Waals forces are what matters. Increasing branch, increased branching on carbon chain increases the boiling point. Sure, but क्यों भाई? It doesn't explain. It needs to explain it. Increased branching reduces strength of intermolecular hydrogen bonding. No, hydrogen bonding नहीं हो रही. These are non-polar substances. So intermolecular van der Waals forces, yes. Which equation represents a valid propagation step? Propagation क्या होती है? You get a radical, you produce another radical. Molecule makes a radical, radical makes a molecule. ये होता है ना? So we can obviously ignore this. यहाँ पे C part तो हो नहीं सकता, because hydrogen radical तो बनेगा नहीं. And what's left? A नहीं हो सकता, because what's happening in A is that the radical has suddenly substituted hydrogen. No, the radical produces a compound and the compound produces a radical. So radical produces a compound here, radical produces a compound here. लेकिन ये radical तो आ नहीं सकता कहीं पे. So I only have B, because बाकी तो फजूल option. This is termination. This is possible, but this is termination. Two radicals combining to make a stable molecule. That's termination. Okay, section B is no longer in your syllabus, so I'm going to skip this one for now. Although I would, अच्छा दो ही सवाल हैं देख लेते हैं, because these questions are really very helpful in clearing your concept. A car has a catalytic converter fitted to its exhaust. On analysis, it's on lower exhaust concentration of nitrogen oxide. Okay, an increase in the surface area of catalyst. Sure, if catalyst has greater surface area, there's more adsorption. With more adsorption, it's able to like reduce the risk of these leaking out. So this is true. An increase in the rate of flow of exhaust gas through the converter. Sure, अगर वो ज़्यादा देर निकलती रहेंगी तो वो equilibrium अगर establish हो जाए तो it will go towards the forward side. ठीक है. A much higher temperature, नहीं भाई उससे तो produce ही और ज़्यादा होना शुरू नहीं. We don't want that. So 1 and 2 only. Chlorine oxide free radical is produced by reaction with chlorine atoms and ozone. Okay. Which features are present in a chlorine oxide free radical? Any radical is one that has odd number of electrons, which are like जरूरी नहीं है, it just has to have unpaired electron. Odd number होना जरूरी नहीं है. So does this one have odd number? Chlorine and oxygen. Yep, chlorine is what 17 and oxygen is what 8. So that is odd number. Single covalent bond CLO, yes. Yes. A dative covalent bond from oxygen to chlorine. No. This is a pretty straightforward. Dative to tab hoti hai na if it has an empty orbital. Chlorine doesn't have an empty orbital, so this can't be right. Define the term mole. Kya hoti hai ji? So the definition of mole was changed a few years back. I think 2018 tha. I think it was my first or second year. Define the term mole. Mole is amount of substance containing Avogadro's number of particles. पहले लोग कहते थे containing same atoms as 12 grams of carbon 12, but that definition was changed, and now it is just an empirical definition, not dependent on any physical thing. Let's see कब change हो रहा था. Okay, Google doesn't know. A small burrowing mammal with dark velvety fur. Yeah. So, yes, November 2018. That is when the new definition came into effect. Okay, 10 cm cube of a gaseous hydrocarbon was reacted with 100 cm cube of oxygen gas. Okay. So we are reacting it. You have the ratio 1 to 10. Okay, and excess. So they've already told us the oxygen is going to be left over. Final volume of gaseous mixture was 95. So some oxygen was used up, and you're getting a mixture of 95 cm cube. This is your initial volume. This was treated with aqueous sodium hydroxide to absorb the carbon dioxide. We know sodium hydroxide reacts with carbon dioxide to produce carbonate. This reduces the volume to 75. So 20 cm cube carbon dioxide was used up. Okay. So write an equation for the reaction between that. So that's pretty straightforward. Sodium, sorry, sodium hydroxide reacts with carbon dioxide to produce sodium carbonate. Okay. And water, yes, water will be the byproduct. Okay. Na2CO3, sorry. Calculate the volume of carbon dioxide present produced by combustion. 20. 95 was initial minus 75. You don't need to show this step. Calculate the volume of oxygen used up in the reaction. So the total volume was 110, and volume of oxygen used up in that reaction with hydrocarbon. Total was 110, and the product was 95, which included 20 carbon dioxide. Which means what was the difference? 75 आ गया, जो कि remaining है oxygen, right? So 75 oxygen is remaining, 100 is the initial, so 25. Does that make sense? Basically, the gaseous mixture is all carbon dioxide and oxygen. And after you remove carbon dioxide, you're left with 75 cm cube of oxygen. So
Sir,
initially you started with 100 of.
why
Why
won't
won't you
start with 110?
Because the 10 cm cube that's used up is not of oxygen but of this thing, and the question is saying what's the volume of oxygen used up. So overall it went from 110 to 75. The difference is 35, but 10 to wo hydrocarbon tha, not oxygen. All right, use your answer together with the initial volume of hydrocarbon to balance the equation. Mole ratio dekh lete hain. I'm using 25 of oxygen with 10 of this to use 20 of carbon dioxide. So mole ratio क्या होगी? 1, इसको simplify कर लेते हैं, 5 से divide कर लेते हैं सबको. So that gives me 2, 5, and what was this? 2. What was this? 20 नहीं था? 2, 5, 4. Okay. Did you use the value of x, y, and z in the equation? Okay. Okay. It's easier if I make this to this 1. So if this is 1, then this is 2.5, and this is 2. So I have x equals to 2 because there's 2 carbon on the right side. And what will y be? Y will be oxygen kitna hai? So I have 5 oxygen in total, out of which 4 is present over here. So 1 is here. So that is z is 1. So if z is 1, then I have 2 hydrogen, 2 to 1. I didn't have to divide it by 2, but I just thought that it will be easier that way. Otherwise, हमें हर आंसर को 2 से divide करना पड़ता बाद में. You can just keep it 2, 5, and 4 if you like that more. That you'll still get the same answer. And I'm using Avogadro's law here. Avogadro's law says that the mole ratio is same as volume ratio for gases. So that's why I'm able to do it. Ethane reacts with chlorine to form chloroethane. Okay. And they haven't shown the intermediate step. Sara usne reaction kara diya. Use bond energies from the data booklet to calculate the enthalpy change for this reaction. Include a sign. Bond energies के लिए what do I have? I have bonds here. HCl की bond है. I have this bond here. I have ClCl bond here, and I have C2H6 bond here. Now, while I can just go on and calculate all the bonds broken and all the bonds made, I wouldn't do that because I don't want to spend so much time on that. If you notice, 5 carbon hydrogen bonds are unaffected during the reaction. Like these 5 carbon hydrogen bonds, unko kuch fark nahi pada. They're broken, they're made. What does it even matter? So I'm not going to concern myself with that. The only bonds that are actually broken are the ones with 1 carbon and hydrogen and 1 chlorine and chlorine. And the ones that are made are 1 carbon and chlorine and 1 hydrogen and Cl. So I'm just going to add these up and subtract these, and I will get my answer. Okay, whatever that is. It will be an exothermic reaction, I think. State the condition needed for this reaction: ultraviolet light and high temperature. Use a series of equations to describe the mechanism. Okay, so you have what? Ethane. Okay, so series of equation में क्या होगा? Initiation, propagation, termination. It's a 5-mark question, guys. So it's important कि आप तीनों stages दिखाएं. All right, so let's start. Neatness will really help. So initiation, I have chlorine molecule breaking down, making chlorine radicals. That's initiation. Propagation, I have this chlorine radical approaching. I don't have to show the structure. I can just write this. Molecular formula is fine. Chlorine radical approaches, makes HCl, makes another radical. That radical then goes on. Uh, Sorry, the radical sign should be on carbon. This radical goes, approaches another chlorine molecule, makes another radical, and C2H5Cl. Yep, there you go. That's my propagation and then my termination. The termination step would be in two radicals joining together. I could have a C2H5 radical joining with chlorine radical making C2H5Cl. I could have C2H5 radical again, sorry, joining with itself to make C4H10. All right, ClCl makes no, like it's not really important, so you can just skip that one. Chloroethane can be converted back into ethane by a two-stage process via an intermediate reaction. Nothing we have studied so far. We haven't studied how to take the Cl out. अभी हमने नहीं पढ़ा. But we know it will involve substituting Cl with something that is easier to remove later on. We will do that. We will study that later on. Like halogen alkanes when we do that. Heptane is an undesirable component of petrol as it burns explosively, causing knocking in an engine. That's why you try to get high octane, जिसमें हेप्टेन कम है और ऑक्टेन ज्यादा है. There are 9 structural isomers with formula C7816, only 2 of which contain chiral centers. Do you remember what chiral centers were? A central atom with 4 different groups. And structural isomers, you have to describe them. Same molecular formula, different structures. We have talked about it in, like, that's the definition we are taught in O levels. So same molecular formula, different structure. Chiral, central atom with joined with 4 different groups, and that is chiral. Okay, you can also talk about that it causes optical isomerism, and there are enantiomers produced. You can talk about that. Give the structure names of 2 structural isomers which contain a chiral center. Chiral center बनाने का तरीका क्या है? You put a carbon in the center. We just defined chiral center, right? So you put a carbon in the center. उसकी 4 bonds होंगी. Fill it up. You have C7816. Go on. I'm just taking a shot here. Hydrogen इधर दे देते हैं. Methyl इधर दे देते हैं. Okay, I'm left with 2 carbon. Okay. And how many carbons I'm left with? 5, right? So 2 इसको दे देते हैं. 3 इसको दे देते हैं. And just fill it up. So I have C2H5 and C3H7. That is 5, 7, 3. Yeah, that's total done. See, so much easier. Yeah. Let's try another one. You go. Try to make a chiral center here. Try to make a compound. One way is really easy. What you do is, instead of thinking of a new compound, just make mirror image of this. So dotted line here, this line here, solid line here, and this H, C3H7, C2H5, CH3. Just make sure you reflect everything. And yep, you have it. That's another enantiomer of this thing. You don't really need that one. You can also, what you can do is that you can make some structural changes here. For example, I could make another similar, like copy this one. So if I copy this one, and instead of assuming that I have straight chain on this side, C3H7, maybe I could get like this thing here, that this is H, and this is CH3, and this is also CH3. Now I've gotten a branch on that side. That's an isomer. Okay. So I needed the structure, so I can just draw the structure of this thing if I want. I will start here and just keep on writing this formula. I'll start here, just keep on writing the formula, start here. Just longest chain basically. All right, so that's it. pretty straightforward. Any questions? You can do the same thing on the other side.
How do we name them?
How do you name them? Okay, pretty straightforward. How many carbons here in the long chain? One, two, three, four, five. So this is pentane. And on the second one, I have a methyl. On the third one, I have a methyl. So 2, 3 dimethyl pentane. Okay, let's name this one. I'm assuming this is a straight chain. So this is a straight chain. I have 6 carbons here, 3 and 4 and 6. So hexane. And the third one, why? Because 2 and then 3, not fourth one. Idhar se nahi aana, udhar se aana. So third one has a methyl group. So 3-methyl hexane. Let's try this one. This is also 3-methyl hexane, but this one is levo and this one is dextro, but हमारे syllabus में नहीं है वो. So we'll just call them the same thing. Write an equation for the complete combustion of heptane, carbon dioxide plus water. I have 8 water, I have 7 carbon dioxide, 14 plus 8, 22 divided by 2. Balanced. Write an equation for the incomplete combustion of heptane, leading to production of solid pollutant. Interesting. We need a solid pollutant. And incomplete combustion produces carbon monoxide or just carbon. So we need
Just
two.
carbon.
Yeah, just carbon. So C7H16 plus oxygen producing carbon plus water. 8 water, obviously, 7 carbon, but now I just need 4 oxygen. So, yep. Incomplete combustion can not lead to emission of unburned hydrocarbons. State 1 environmental.
Sir, greenhouse effect.
Greenhouse effect. Don't we need that?
Like enhanced greenhouse effect.
Yes, enhanced greenhouse effect leading to what?
Ozone
Why is
depletion.
that? We need to talk about consequence. What's the problem with that? Enhanced greenhouse effect. होता क्या है उससे? Yeah, global warming, sea levels rise, flooding of low-lying areas, melting of ice, polar caps, all of that. Yep. So that is the sorry consequences of these things. डर आता है सुन के. Name the mechanism of the reaction between heptane and chlorine in the presence of ultraviolet light. Free radical substitution. You can just complete this. ठीक है. Describe this mechanism using suitable. See, दोबारा वही सवाल आ गया 5 नंबर का. But what they've done is they have taken another alkane. पिछली दफा हमारे पास ethane था, बुक में हमारे पास methane था, and here we have heptane. Method stays the same. All you're going to do over here, if you go back to that question that we had, here copy exact same thing. Okay, and we can write it again just by switching the formula of the hydrocarbon we use. So if I take this one, now all I need to do is change wherever I have this thing, change that. And that's it. That's all I need to do. जहां जहां hydrocarbon है वो बदल जाएगा. So yep, C7H16, C7H15. That's my radical. C7H15, C7H15, making C14H30, C7H15, C7H15, C7H15. Yeah. Okay. Same thing. Same thing. 5 नंबर मिल गए. आसान है. Crude oil is a mixture of hydrocarbons. Okay. The diagram is a simplified representation of fractional distillation. Okay. What has to be done to the crude oil before it enters the column? Of course, we have to vaporize it. Because other than if we don't get vapors, they won't cool down and make liquids that we can separate. What trend in structure is there from fraction A to fraction F? They are becoming structure पूछा उसने. So carbon की बात कर लेते हैं. They have longer carbon chains. Because
Sir,
that's
what
how
do we
we
have
come
to do
to
to the crude oil before it enters the column?
We have to vaporize it. You're
Okay.
separating fractional distillation is all about vaporizing things and separating based on boiling point. State the trends in 2 properties of fractions. What are the trends? As this has low melting point, this is more volatile, and it is more flammable because it's a smaller molecule, burns more easily. Okay, and as you go down the chain, they change. You get higher boiling points, higher density, higher viscosity, higher lower volatility, less flammability, all of those trends. Okay, the naphtha fraction from fractional distillation is used as starting material for cracking. Yes. Write an equation for the cracking of C12H26. Okay, so C12H26. What do I need? I need to crack it, which means no oxygen, catalyst, high temperature. All right, 2 to 1 mole ratio में मुझे क्या चाहिए? Ethene and one other hydrocarbon. Ethene, so C2H4. I need 2 to 1 of this. So let me just put 2 there. So 2 times 2 is 4. What am I left with? 4 ये हो गया तो पीछे 8 बचा. So C8H. I needed a 2 to 1 ratio to बना ली मैंने. Just a use for each of the products from your equation. So we had ethene and we had, what was the other thing? C8H18. उसको तो fuel बना लेते हैं ना. The other use is fuel because it has is it alkane? Yep, this is alkane. So alkane has it releases a lot of energy when you burn it. So releases energy when combusted or when burned. Ethene is used to make plastic bags, or you can just call it polythene. Okay, and that polythene can be used. And why is ethene useful for that? Because it is an alkene, it has a double bond. Okay, so explanation is that it can do addition reaction due to the carbon-carbon double bond. Okay, burning hydrocarbons can cause a number of environmental. Explain how and why oxides of nitrogen produce internal combustion engine. We have talked about this before. High temperature in the internal combustion engine, it provides the activation energy needed to break the nitrogen bond, and that is how it's able to form these oxides where reacting with oxygen. उसकी equation भी हमने देखी हुई है. Nitrogen monoxide plus carbon monoxide makes nitrogen plus carbon dioxide. Right, going to show the involvement of nitrogen monoxide in the formation of acid rain. Again, you know that nitrogen monoxide oxidizes to produce nitrogen dioxide. That nitrogen dioxide is a catalyst for oxidation of sulfur dioxide. So SO3 plus NO, and that नहीं उसने formation of acid rain बोला है. So NO is the catalyst in this case, and then this NO, this SO3 can dissolve in water and produce acid, which is obviously the reason of acid rain. So we have to give 3 equations. So वो acid rain वाली बात हो गई. Describe 2 problems associated with acid rain. Damages the buildings and changes pH of water bodies. That kills aquatic life. Those 2. Marble buildings get destroyed. And okay, let's do this one. Hydrocarbon A, C4H10, okay, and B, C4H8 are both unbranched. Straight chain. A does not decolorize bromine. So that shows there's no double bond. Saturated, that's what it means. Saturated. It decolorized, so unsaturated. Geometrical isomers, definitely double bond. Okay, and cis trans, that's what it means. Skeletal formula of A, 4 hydrocarbons at the 1, 2, yeah. So 1, 2, 3, 4. 4 hydrocarbons. 4 carbons, sorry. C4H10 has a branched isomer. Okay. Why does unbranched have a higher boiling point? We've seen this before. The branching makes the molecules pack more, so there is less surface area, weaker intermolecular forces, lower boiling point. Or if you want to talk about why it has higher, so unbranched A has greater surface area for molecule again, okay? Stronger intermolecular force of attraction, higher boiling point. इसको आप phrase कर दें. Yep. I would suggest कि we have done 5 questions. बाकी आप try करो खुद से करना.